Hello, everybody, and welcome to another visual pattern challenge. Today, we've got a big one. Here is step 1 in this pattern. Here's step 2, 3. They've even given us step 4. And your challenge is to predict the number of squares in step 5. If you can do that, and I think already at step 5, this is going to be a pretty big number. If you can do that, can you predict the number in step 43? I think it's going to be truly massive. And can you write an equation that you could use to predict the number of blocks in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, this one looks big. It starts kind of big and it grows pretty quickly. So I'm pretty sure we're not going to find a linear pattern here. There's something else going on. And I think by the end of this, we're going to have some really big numbers. Um, hmm. You know, we could start here by trying to get some visual intuition. And I guess what I'm going to do is just count the rows and see how that's growing. So we've got 1, 2, 3 rows here, and 1, 2, 3, 4, and 1, 2, 3, 4, 5. There are 6 here. Aha. So I would say in step 5 here, in the next step, there should be 7 rows. 4, 5, 6, 7. Okay, so I'm saying 7 rows. The other thing I notice is that one of them is short. So this top one is going to be shorter than the others. Let's look at the long rows. On the bottom we have, well, there's 3, and then that's 5. Yeah, that's 7. Okay, so this should be 9. Yeah, that's 9. So I'm guessing these bottom rows should be rows of 11. So I'm just going to fill that in here. So 6 rows of 11. Wow. So far 6 times 11. And then our top row, it's 2, and then 3, and then 4, and then 5. So it looks like it's just 1 less than the step number. So I would guess this should be 6. Sorry, 1 more than the step number. This should be 6. So we've got 6 rows of 11 plus 6 more. So that's 66 plus 6. That's going to be 72. So I think at step 5, we're already up to 72. Now, usually what we do is we create a chart and we analyze the numbers. I think I'm going to make my chart a little bit different here. I'm still going to put the step number here, but I'm going to make some room to really kind of sketch out what I see happening. And what I see happening is there's a rectangle in each one of these with a chunk missing. And I notice that the chunk here is 1 square, and then 2 squares, and then 3 squares, and then 4 squares. So I know that the chunk missing is the step number, and that's the key piece of visual intuition that's leading me to this style of analysis. So for step 1, what I've got is a 3 by 3 square with the step number missing. So this is 3 by 3 and minus the step number, minus 1. In step 2, what have we got? It's 4 by 5 minus the step number, minus 2. And in step 3, it's going to be 5 by 7 minus the step number. In step 4, we're going to have 6 by 9 minus the step number. And I won't even put step 5 on here. It's going to follow this same pattern. And it's this pattern that we're seeing here that we're going to use to create an equation. So what I notice is that this part, this is the step number. So we've got a minus x here. Then to make this part, it's 3, 4, 5, 6. Well, what is 3 in step 1? Well, it's 2 more than the step number. And what is 4 in step 2? Again, 2 more than the step number. So this first number is always 2 more than the step number. So I'm going to write that as x plus 2. And then how about this one? How do we get 3, 5, 7, 9? Now it's going up 2 each time. So it's not just the step number plus something. It's actually, let me put parentheses around here. It's actually 2 times the step number. And then 2 times 1 would be 2. To get 3, we'd have to add 1 more. So I think the formula for just this number is 2x plus 1. You might want to double check. Is that in step 2, would that give you a 5? 2 times 2 plus 1. Yeah, that would be 5. 2 times 3 would be 6 plus 1 is 7. Yeah, so that's giving you the step number. Now we've got x plus 2, that's this number here, times 2x plus 1, that's this number here, that's giving us the big rectangle, and then we're subtracting the part that's missing, the x. So this is our equation, x plus 2 times 2x plus 1 minus x. If you want to keep the equation in that format, I think it's actually useful for seeing what's happening here. You can also just FOIL all that out and simplify it. And let's see, I think what you get is 2x squared plus 4x plus 2. You may want to double check that, but I think that's the equation. And I'm going to leave it in this form because it's a little simpler to crunch the numbers. So that is what I'm going to do. And I'm going to write that here. So y equals 2x squared plus 4 times x plus 2. So basically, we're taking the step number and squaring it, multiplying that by 2, then taking the step number and multiplying it by 4, adding those two together and adding 2 more, and that should give you what you've got going on here. For step 43, that's going to be a really big number, but we can find it just by crunching that out. So 2 times 43 squared plus 4 times 43 plus 2. Now 43 squared is 1849, so we want 2 times 1849 plus 4 times 43. Let's see, 4 times 40 is 160, so 172 with the 4 times 3 is 12. So 172 and then plus 2 more. And 2 times 1849, that is 3698 plus, and I'll put these two together, 174. Let's see, is that going to be 3,872? I think. Well, double check that number, but that's what I'm getting, 3,872 in step 43. Pretty big number of squares. Well, how did that go for you? Did you use this same kind of visual intuition? Did you look at the numbers and analyze it in a different way? This is the first time we haven't taken the difference between steps. Let me know. Thanks, everybody.